Hello, ladies and gentlemen. Welcome to section 4 of chapter 6. We're dealing with scientific notation. What scientific notation does lets us to write really big numbers or really small numbers in a nice, easy form. Usually, when you take big numbers and you multiply them on your calculators, they put it into scientific notation for you. That's why you have little numbers over on the side of your calculator, and we'll talk about that later on. Couple rules for scientific notation. General form is a times b raised to the b power, or a times 10 raised to the b power. A is some number between positive or negative 1 and positive or negative 9.99. Okay, so it can't be 10 or bigger. It can't be a number that's less than 1. B is the number of values that we're going to move our decimal point. If we're going from standard form or to scientific notation or vice versa, and it can be a positive or negative number. So let's take a look here at a couple different examples. What we have is 3.5 times 10 to the ninth. That's one big number. What that means is we've got 3.5. This 10 to the ninth tells us we're going to move 9 spots right with our decimal. So we have 3.5. We're going to move it 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We put our new decimal there. Now, because we were doing that, we have all these empty spots here. We put in zeros wherever we don't have numbers. Okay, so we placehold it with zeros. So that means this number is actually this very big number here. I believe that would be 3,500,000,000. Okay, so 3.5 times 10 to the ninth, written in standard form, is this. Okay, and so we can see this is kind of icky, kind of messy. So we prefer, if we have something that looks like this, we can write it in scientific notation. It looks a lot better. Now we also have this next one. It says 4.5 times 10 to the negative 8. Because this number, our exponent, is now negative, we move 8 spots left. Okay, so we start with 4.5. We'll move over here, 4.5. We move 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8. Put our decimal point there. So now we have 1, 2, 3, 4, 5, 6. We have all those zeros. Put another 0 in front to go in front there. So this number here, because it's a negative exponent, gives us a very, very small, small number. Okay. This last example, we've got 36 times 10 to the sixth. Hopefully we realize that this number right here, 36, is not between 1 and 10. So we need to make sure, we need to change it to make it between 1 and 10. So that means we have the decimal point here. If we move it 1 spot to the left there, it's going to make it 3.6. But because we moved the decimal spot 1 spot to the left, that means we have to change our decimal point, or we have to change our exponent here as well. All right, and so what this means here is because we are moving this decimal spot 1 place this way to the left, we are going to change this exponent and make it into a 7, because if we write this out as 36 and then we had 6 zeros behind it, 1, 2, 3, 4, 5, 6, actually in true scientific notation we'd move the decimal spot 7 points to get it in between 3.6 there. So this is just something to show that we need it to actually look like this, so that it is in true scientific notation. All right, so we move the decimal spot here from 36 to 3.6. We add one more spot. It'd be the same thing if we had 0.36 times 10 to the 7th. We would move it one spot to the right, which make it 3.6 times 10. And because we moved it to the right, this moves down 1, becomes 10 to the 6th. Okay, so this is just a little something to help us out there. Now we can also be given these very big numbers and go from big numbers to standard or scientific notation. So what we have here is we have 72,000. We got to go to scientific notation. So what that means is we're going to start with our decimal spot. We're going to move it until we get to a number that is small or between 1 and 10. So we're going to move it 1 spot, 2 spot, 3 spot, 4 spots. So that gives us our new number is 7.2. We times that by 10, since we moved the decimal spot four times, 1, 2, 3, and 4, our exponent becomes 4. Okay, so we move it to the left, so it makes it a positive 4. Here we have 0.000086. We want that in scientific notation, so we're going to start here, move it 1, 2, 3, 4, 5, so our number becomes 8.6. We'll multiply that by 10. 1, 2, 3, 4. We moved it 5 spots, but because our number was small, our exponent is negative. Okay, and then the last example here, we have 4,200,000,000. And we can count 1, 2, 3, 4, 5, 6, 7, 8, 9 spots is how much we got to move it to give ourselves a number that's between 1 and 10. So that's 4.2 times 10 to the 9th. Okay, so and then the last thing we're going to talk about here is multiplying scientific notation. We've got 2.2 times 10 to the 4th. We're multiplying that with 2.6 times 10 to the 6th. When we multiply scientific notation, we take the big numbers and we multiply those together first, so that 2.2 times 2.6 gives us 5.72. And what we do here is then we take our exponents and we add them together. That gives us 10 to the 10th power. We'll take a look at this next example. We've got 2.4 times 10 to the 7th times 8.3 times 10 to the negative 4th. Okay, so we have 8.3 times 10 to the negative 4th. So we're going to multiply our big numbers together. We get 19.92 times 10. We've got 7 and negative 4. We add those together. That gives us 3. But hopefully we see that this is too big. So we need to change it to 1.992 times 10. And because we moved the decimal spot to the left, that gives us an extra exponent. And we have times 10 to the 4th. Okay, so this is scientific notation. Make sure that if you have any questions, that you let me know in class, and have a good day.